Assalamualaikum warahmatullahi wabarakatuh and good day to sir. So today our group will present you the project of the PPT report for our group. So first of all, I will introduce my group members. I am Haris Irfan and we have Takif, Shah Hafizul Haziq, Adi Amzar and also Afif Azim. So in this presentation, we will divide it into three parts, which is PPT concept, PPT report analysis, which based on the question, and also for the conclusion.
Now for the PVT concept. PVT analysis is a key component of reservoir fluid characterization, used to predict how oil and gas behave under reservoir and surface conditions. In the PVT lab, we observe experiments that measure critical parameters such as bubble point pressure, solution gas-oil ratio, formation volume factor, and oil and gas viscosity under pressure. The PVT cell was used to replicate reservoir pressure and temperature, allowing us to observe phase changes, such as gas coming out of solution as pressure drops. These measurements support the design of material balance calculations, reservoir simulation models, and surface separation facilities. The lab visit bridged theoretical knowledge with practice, deepening our understanding of how PVT properties directly impact reservoir management and product optimization.
So, for my part, I want to briefly discuss about the experiment and test that we have been showed during our visitation to PVT lab that consists of basically three main tests and experiment. So, first of all, I will briefly about how the constant coefficient works, which is CCE, which stands for constant coefficient composition test. First of all, we load the reservoir fluid sample into a PVT cell and set the temperature to the reservoir temperature. And after that, we increase the pressure to match or slightly exceeds the initial reservoir pressure and then begin a stepwise expansion by increasing the cell volume. We subsequently reduce the pressure in the PVT cell. At each pressure step, we measure the pressure and the total volume of the fluid by recording the VT, which includes the both liquid and gas volume below the bubble point. So, after continually reducing the pressure in increment down to atmospheric pressure, and after that, we can finally plot the total volume VT against the pressure. That's what we can gain from this test is the info or data about the fluid below the bubble point pressure. Like I have shown in the slide, which is the oil compressor for the fluid below the bubble point, which is for this sample, it can say that 2820, which is the considered the bubble point of this fluid. So below the bubble point of it, the data is from the CCE test. Most of the next test that I want to discuss is about the differential liberation test, which how it works is basically like placing a reservoir fluid into a PVT cell at reservoir temperature and bubble point pressure. So then we increase the pressure in the PVT cell gradually by increasing the cell volume increment. So while the liquid is agitated to ensure equilibrium between gas and liquid phase, and we need to make sure that each pressure step the gas is being removed from the cell and the volume of remaining liquid is being measured and recorded. So the pressure is keeping constant by reducing the cell volume as the gas is removed. Therefore, this process is continually and gradually until the pressure reaches atmospheric pressure. So, so by the end of this test help to determine the gas oil ratio RS and formation value factor and other property, and that we can conclude that the data from the PV from the test is crucial to determine the fluid behavior above the bubble point pressure. So basically, constant coefficient composition CCE may look maybe like the same to differential liberation test, but what can I say that the data that we can get from this test is different. For example, CCE test provide the data about the reservoir fluid behavior below the bubble point, but the differential liberation test provide us the data about the fluid behavior above the bubble point. And also during this test, the composition in the PVT cell during CCE test is constant because the PVT cell is a closed system, while during the liberation test, the composition in the PVT cell is not constant because the gas is being removed gradually from the PVT cell. Therefore, the composition is keep changing over the time. So last test for the PVT analysis is a separated test. So separated test is involved by placing the reservoir fluid sample in a PVT cell at a reservoir temperature and bubble point pressure. And after that, the pressure is then being reduced stage by stage. So basically, they have two stages. First of all, the gas is separated from a liquid at a lower separated pressure and then move to the second stage is the remaining liquid is moved to the stock tank while the gas is being expelled. And after that, the pressure is in the cell is kept constant by reducing the volume of the gas as the gas is being released. Therefore, the optimum condition for separator pressure and temperature is chosen by the operator, and the stock tank is always maintained at an atmospheric pressure. Hence, the separator test is crucial for petroleum engineers to help to determine the gas oil ratio and the other fluid property for the reservoir analysis. So just now I have mentioned that the optimal separator condition. So now I want to discuss about the optimal separator condition that is crucial for the PVT analysis in a further discussion. So the optimal separator pressure is the pressure that maximizes stock tank liquid production. It results in the minimum gas oil ratio RS and the minimum formation value factor BO at the bubble point and the maximum oil gravity API. So basically for most black oils, this pressure typically range from 100 to 120 psij at normal temperatures. Therefore, the operator need to set the separator to the optimum pressure to maximize the stock tank of the liquid production.
So for the saturation pressure, which is question 1A, we need to identify it according to PVT data, best case embed, which is correlation, and also plug-in. For the sample one, from the PVT data, we got 2,672 KSIA, which is the data given in the report. And the specific gas at that particular pressure is 0.785. And then for the best case embed, we need to use the formula of the correlation as in the SPE test. And then we plug in the value into that equation, and then we will get a value which is 2000 something, which lower than the report value. So that we need to use the goal seek function in this situation in order for us to alter the value to get the correct answer, which is 2672. Same goes to the plug-in value, which is initially we got differ from the exact value, and then we use the goal seek function, which is within the 2672 SIA. The same things apply to the sample 2, which is first we need to use the formula and also the plug-in equation, and then we need to use the goal seek function in order for us to get the exact value, which is 3086 psia. And then for the oil compressibility, we need to calculate it accordingly, which is plug-in, correlation, and also PVT calculation. And then for the plug-in, just key in the formula in the Excel, and then we will get this value. And for the correlation, we need to use formula, which is two different formula for above bubble point and also below bubble point. And then we will get this value. And for the PVT calculation, we need to use the PVT analysis formula as stated in the SPE text, and then plug in all the value, and we will get this answer as stated here. And then for the, just look at the analysis. For the sample one, we got, for above bubble point, we got this trend graph. So as the pressure increase, the oil compressibility will decrease. So this is because above bubble point, the oil is undersaturated, which is no gas coming out. And then for the below bubble point, as the pressure increase, the oil compressibility will decrease quickly, but still remain in the bubble point. This is because the gas started to come out from the solution, which is make the oil expand rapidly. And then for the sample 2, we got this trend line for the above bubble point and also below bubble point. If you look at here, the correlation and the plug-in graph or line is same, because as we know that in the plug-in, it also applied the viscous and Beck's correlation. So that's why we get this value. And for the concept, it is similar to the sample one theoretically, but it may have some difference because of the data and so on.
Previously I described how the data from below and above power point are being recorded using CCA and DL test. And now I want to explain the result by mixing these two data, which resulting a graph of BO and RS. So firstly, I will discuss about the BO first. In sample number 1, we use all the three methods, which is PVT analysis, correlation, and plug-in methods. Which we can see that it follow a similar general trend. So basically, BO increased with pressure up to a certain point around 2670 psia, which is the maximum BO after which become relatively stable or slightly decrease. So this peak typically correspond to the bubble point pressure where the maximum of the gas is dissolved in oil, causing the expansion. So beyond this pressure, as a gas remains fully dissolved and the oil compressibility dominates. So the correlation method showed the highest BO peak and slightly above the PVT analysis and plug-in result for the sample number 1. And move to the next sample, which is sample number 2. The BO value also rise with a pressure peaking around 3000 psia and then gradually decrease with a further pressure increase. This behavior is typically because below the bubble point, the addition of dissolved gas causes oil to expand, resulting BO to increase. But above the bubble point, the compression is going through that will resulting a reduce in BO values. So we can see that all the three methods, which is PVT analysis, correlation, and plug-in, display a consistent trend, although a minor differences might be visible. So the correlation method slightly overestimate BO compared to PVT analysis, especially at high pressure. So the graph for both sample, we can conclude that it followed the expected trend of BO versus pressure graph. So the next graph that I want to discuss is about the graph of solution gas oil ratio, which is RS. So basically, in sample number 1, we can see that the relationship between the pressure and the solution gas oil ratio using three main method, which is PVT analysis, correlation, and plug-in method. So we can see that the RS increased linearly with pressure up to approximate 2670 psia, reaching a maximum value of RS that is around 639 square feet per STB. So basically, beyond this maximum value, the RS will remain constant. This behavior marks the bubble point pressure, where the oil became saturated with gas and no additional gas can be dissolved. So although the legend mentioned correlation and plug-in method, their data is not visible in the plot because they are overlapping with each other because of their same value. And move to the sample number 2, we also use all the three methods, which is PV analysis, correlation, and plug-in method are being shown and being compared. So basically, RS rises with the pressure up to about 3080 psia, where it is at approximately 619 square feet per STB, indicating the point is the bubble point pressure. While below the bubble point pressure, it has a slightly differences are being observed among the three methods, which I can say that PVT analysis predicts the highest RS value, suggesting a more gas is dissolved at lower pressure compared to other two methods. So basically, the correlation shows a more gradually rises, while the plug-in method lies somewhere between the two methods. So overall, for the graph trend below the bubble point pressure, RS increase with the pressure as the more gas dissolved in oil. And for the above the bubble point, RS reach its maximum and stay constant because the oil is fully saturated.
Now, I will explain to you about what we learned from this project. Okay, first, we can understanding the bubble point pressure. During the lab visit, we observe how the bubble point is identified using a PVT cell through the constant convolution expansion (CCE) process. The lab assistant explained the workflow and equipment used to detect gas breakout. This helps us in part A of the report, where we calculate saturation pressure using correlation and XL plugin. Understanding the real method made it easier to compare my calculated result with actual lab data. Second is oil compressibility testing. The assistant explained how compressibility is measured by observing fluid behavior above and below the bubble point. We learned how pressure-volume relationship are used in the lab to calculate this property. This directly supports part B of my report, helping us interpret compressibility values calculated using correlation and compare them with the lab data more meaningfully.
So for the third part is separator conditions and optimization. So we will introduce to the separator unit and how changing its pressure and temperature settings affects GOR and oil recovery. This explanation helped us in part C, where we analyze separator data to determine optimal conditions. Knowing how the equipment works made it easier for us to understand the trends in GOR and formation volume factors shown in my plots. And for the last part, we understand is the BO and RS trends. Through the lab walkthrough, we learn how BO and RS, which is solution gas oil ratio, are measured during pressure depletion, particularly using differential liberation methods. The assistant explained how pressure impacts gas release and fluid volume. And this helped us in part D, where we plotted BONRS versus pressure and compared the results with lab data and improving our interpretation of the trends. So although we didn't perform the test, and seeing the equipment and hearing the explanations gave us practical context for the PBT analysis. It helps us connect theory to real world applications, making our report analysis more informed and accurate. This visit added value to every section by deepening our understanding of how lab data is generated and used. Thank you. That is all from our group. Thank you so much.